In this video, we'll look at the rational zeros or roots theorem. So the factor theorem tells us that finding the zeros of a polynomial is essentially the same thing as factoring it into linear factors, that is, things that look like x minus c. So now we'll look at some methods to help us find the real zeros of a polynomial and thereby factor any polynomial. So we'll start with the motivation for the rational zeros or rational roots theorem, and then we will formally get to it and do a quick example. So to begin, consider the polynomial p of x equals x minus 2 times x minus 3 times x plus 4. If we were to expand this, and I'm not going to do all the steps, but if we were to expand this, we would get something like x cubed minus x squared minus 14x plus 24. And we also notice that the zeros, in this case, the zeros of the polynomial are x equals 2, 3, and negative 4. It's interesting to note this relationship between the zeros 2, 3, and negative 4 and the constant term of the polynomial 24. In fact, 24 can be broken down as negative 2, negative 3, and positive 4. That is, the zeros of this polynomial are factors of the constant term. And this happens to be, in general, true. And this leads us to the rational roots theorem, or the rational zeros theorem. If the polynomial p of x, which equals a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus plus a1x plus a sub 0 has integer coefficients where a sub n and a sub 0 are both not equal to 0, then every rational zero of p is of the form p over q, where p and q are in the integers, and p is a factor of the constant coefficient, i.e. the constant term, a sub 0, and q is a factor of the leading coefficient, a sub n. So this just says if we do an analysis of both the first coefficient in front of the x with the largest power and factor the last term, the constant term, put those in ratio with one another, we can find pretty quickly the zeros of a polynomial. So I'll give you all a nice kind of algorithm, nice process by which to find the zeros of a polynomial. So there are 3 steps. First, list the zeros. 2, start dividing into whatever polynomial we have, and then just repeat from there. So by the rational roots theorem, a possible rational zero of p equals the factors of the constant term, in this case the factors of 6, over the factors of the leading coefficient, in this case 2, factors of 2. So first, what are the factors of 6? So 6 we can say is 1 times 3. So 6 we can say is 1 times 6 or 2 times 3 paired with a positive or negative. So we say that 6 plus or minus 1 plus or minus 6 plus or minus 2 plus or minus 3. And I'm just pairing each one with the other multiple that makes 6. And the factors of 2 are just plus or minus 1 and plus or minus 2. So if we were to list all the possible rational zeros of p, we would do all the factors of 6 over factors of 2. So each combination. So we'd say like plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 3 over 1, plus or minus 6 over 1, and then plus or minus 1 over 2, plus or minus 2 over 2, 1 over 2, plus or minus 2 over 2, plus or minus 3 over 2, and plus or minus 6 over 2. Of course, 6 over 2 is the same thing as 3 over 1, and 2 over 2 is the same thing as 1 over 1, so we can just cross those out. So altogether we have the possible zeros, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus a half, and plus or minus 3 halves. So now at this point we can grab something, grab some number, one of these possible rational zeros, and test to see if one of these is in fact 0. So I think it's most convenient to use synthetic division here because that's quick and efficient. So let's start with just positive x equals 1. So we have 1, we have 2, 1, negative 13, and 6. Scroll down. And then if we do this, we drop down the 2. 1 times 2 is 2. 1 plus 2 is 3. That gives us 3, negative 10, and then negative 4. So what this tells us is that 1 is not a 0. Not a 0. So now let's try positive 2. 2, and again we have 2, 1, negative 13, and 6. So we drop down the 2. 2 times 2 is 4. 1 plus 4 is 5, 10, negative 3, negative 6, and 0. So this tells us that x equals 2 is a factor, is a 0 of the polynomial p of x equals 2x cubed plus x squared minus 13x plus 6. So now that leaves us with 2x squared plus 5x minus 3 and x minus 2. And that's p of x. Now at this point you could keep testing values, or once you get to something that's simpler, maybe something of degree 2 or 3, then you can try to factor based on our other techniques at that point. But I would encourage you to follow this through and see if you get x minus 2. And then the other two zeros are 2x minus 1 and x plus 3. Those are the other two factors. In other words, x equals a half and x equals. So in this video, we looked at the rational zeros or roots theorem, looking at the factors of the constant term over the factors of the leading coefficient, which helps us find factors or zeros of a polynomial quicker than we can factor or use other factoring technique, or proceed using synthetic division to find the other factors or zeros of any given polynomial. In the next video, we'll look at Descartes' rule of signs, which will make it easier to determine how many zeros of a particular sign we have.